All right, detectives, welcome back. Today we're cracking a classic geometry mystery, the case of the parallelogram. We're going to be looking for clues, gathering evidence, and by the end of this, you'll have everything you need to prove your case, every single time. So let's start with a real-world puzzle. Take a look at this amusement park ride. You see that shape, ABCD, made by the platform and the arms? It's always moving. Now we're told the platform stays parallel to the ground, but is that enough? How do we know for sure that this shape stays a perfect parallelogram as it swings back and forth?
I mean, it definitely looks like a parallelogram, doesn't it? But here's the thing about geometry. Looks like just doesn't cut it. We need proof. We need cold, hard evidence. So the real question is, how do we go from I think it is to I can prove it is?
And that's where geometry comes in. It gives us this amazing toolkit, a set of rules and theorems that just completely eliminate any guesswork. This isn't about what feels right, it's about what we can prove with pure logic. So let's open up the kit and check out our tools.
Our investigation is going to start with the most fundamental clues, the sides and the angles of the shape. These are the first two tools you'll need to crack pretty much any case. Okay, our first couple of tools are super straightforward. Tool number one, if you can show that both pairs of opposite sides are congruent, the exact same length, then boom, it's a parallelogram. Case closed. And the second tool works the same way, just with angles. If you can prove that both pairs of opposite angles are congruent, you've got yourself a parallelogram. Simple, powerful, and really effective.
Okay, theory's one thing, but a good detective has to know how to use their tools out in the field. So let's take that first theorem for a spin with a classic find the variable problem. All right, here's our mission. We need to figure out the values for x and y. That'll make this shape a parallelogram. So let's grab that first tool. Opposite sides have to be congruent. First, let's set side PQ equal to its opposite, SR. That gives us an equation. X plus 9 equals 2x minus 1. A little algebra, and we find that x has to be 10. Easy enough. Now for the other pair. PS has to equal QR. So y equals x plus 7. And since we just figured out that x is 10, we can just plug that in, and y has to be 17.
And there you have it. When x is 10 and y is 17, both pairs of opposite sides are congruent. Our first theorem confirms it. This shape is, without a doubt, a parallelogram. Case closed.
Awesome. Now that we've got the basics down, let's check out something a little more advanced. Every good detective loves a shortcut, and when it comes to parallelograms, that shortcut almost always involves the diagonals. So our next tool is incredibly handy. You only have to look at one pair of opposite sides, just one. If you can prove that single pair is both parallel and the same length, you're done. It's a parallelogram. Then we have our fourth tool, which might be the coolest one of all. If the diagonals of a shape cut each other into two equal halves, if they bisect each other, then that shape has to be a parallelogram. And check this out. This is a perfect real-world example of that shortcut. This old doorway in England is leaning, right? But we can still prove it's a parallelogram. The top and bottom of the door, ST and UV, they're parallel. And since they were built to be the same length, they're also congruent. One pair of sides both parallel and congruent. That's all the proof you need. It's actually why these properties are so important for architects and engineers. Okay, time to put that diagonal tool to work. For this shape, C, D, E, F, all we have are these expressions for the diagonal pieces. But we know the rule, right? For this to be a parallelogram, those diagonals have to cut each other exactly in half. That means segment FN has to be equal to segment DN. So let's set up the equation. 5x minus 8 has to equal 3x. So let's solve for x. Bring the 3x over, you get 2x minus 8 equals 0. Add the 8 to the other side, 2x equals 8, and that means x equals 4. And if you plug that 4 back in, you'll see both segments, FN and DN, are 12. Perfect bisection. Proof complete. Okay, you're getting really good at this. So for our final challenge, we're going to up the difficulty a bit. We're taking away all the given lengths and angles. This time, our investigation is on the coordinate plane, where all we have are points on a grid. So here's our final suspect, quadrilateral ABCD. We've only got 4 points on a grid. Now, the rules haven't changed, but how we get our evidence has to. We've got to use formulas now. So can we prove this is a parallelogram? You bet we can. Let's use that awesome shortcut tool again.
prove just one pair of sides is both congruent and parallel. We'll pick on sides AB and CD. First up, are they congruent? For that, we need the distance formula to find their lengths. When you crunch the numbers, yep, both of them come out to the square root of 29. They're congruent. That's one check. Now, are they parallel? We'll use the slope formula for that. And guess what? The slope for both lines is 2/5. Same slope means they're parallel. That's check number 2.
And that's it. We did it. We've proved that one pair of opposite sides is the same length and has the same slope. Our trusty theorems tell us there's no doubt about it. ABCD is a parallelogram. See, the grid can't hide the truth.
So, after all that sleuthing, what's the big takeaway? We've basically built a master key, a 5-point checklist that'll crack the case on any quadrilateral you come across.
This right here, this is your master key. It lays out all 5 ways you can prove a shape is a parallelogram. Think of it as your final case report, the whole solution in one neat package. So you now have 5 powerful tools in your detective kit. You can show both pairs of opposite sides are parallel, or that they're congruent, or that both pairs of opposite angles are congruent. You can take that shortcut and prove just one pair of sides is both congruent and parallel. Or you can just check if the diagonals sliced each other in half. Any one of these will get you the proof you need. So there you have it. You've officially graduated from the Detective's Guide to Proving a Parallelogram. You've got the tools, you've got the know-how, but you know how it is. Every solved case just leads to a new mystery. We all know a rectangle is a kind of parallelogram, but what's that one extra clue that makes it a rectangle? That's something to chew on for our next investigation.